Hi, my name is Kimberly Garcia, and I'm going to be talking about the 5 sensory receptors. So what is a sensory receptor? These are specialized cells that respond to specific stimuli in our environment. They send signals to our brain, helping us perceive what's around us. An important thing to know is that each of our senses has a unique receptor. To start off, we have hearing, or the auditory sense, and that is our ability to detect sound wave vibrations. The receptors are hair cells, and they're located in the cochlea, a spiral-shaped part in the inner ear. It looks like a snail. It's this right here. How it works is that sound waves travel through the outer and middle ear until they reach the cochlea, where they create fluid waves. These waves bend tiny hair-like structures on the hair cells called stereocilia, generating electrical signals sent to the brain. We perceive this by the auditory nerve carrying the signals to the brainstem and then to the auditory cortex, where the sound is identified and interpreted. You must know that there's different areas in the cochlea that respond to different pitches, allowing us to differentiate sounds. Then we have taste, or the gustatory sense, and that allows us to identify flavors. The taste receptors are known as taste buds, and they're located on our tongue and the roof of our mouth and throat. They're housed within these circular shapes called papilla. We have different types: fungiform on the front of our tongue, filiform on the tip of our tongue, and foliate on the side of our tongue. How it works is that when we eat, we have these molecules called tastants, and that causes taste sensations. They bind to specific receptors on the taste buds, and then they send signals to the brain via cranial nerves. We perceive this by the brain processing these signals, combining taste with smell and texture to create the overall flavor. So for example, sweet receptors detect sugars. Following that, we have smell, or the olfactory sense, and that is our ability to detect airborne chemicals, helping us perceive a range of odors or odorants. The receptors are olfactory receptors, and they're located within the nasal cavity in the olfactory epithelium right here. How it works is that they follow a specific path and they bind to the olfactory receptors, which make electrical signals that travel to the olfactory bulb, which is right here, and then they go to the brain that's responsible for interpreting smells, such as the olfactory cortex. We perceive this by processing the signals in areas linked to emotion, memory, and conscious perception, and that is why smell is closely linked to them. Then we have sight, or the visual sense, and that lets us detect light, color, and shapes. The receptors for sight are photoreceptors. We have rods and cones, and they're located in the back of the retina right here. How it works is that when light hits these photoreceptors, it causes a pigment change that triggers electrical signals. So rods here help us see in dim light, while cones here help us perceive color. And how we perceive this is that these signals first go down to the optic nerve right here, and then they travel to the brain's visual cortex, where we actually interpret images, color, and movement. Lastly, we have touch, or the somatosensory sense, and that allows us to detect pressure, temperature, and pain. We have 3 different types: mechanoreceptors that detect pressure and vibration, thermoreceptors that sense temperature, and nociceptors that register pain. More on mechanoreceptors, we have Meser's corpuscles, and they're sensitive to light touch. Then we have Pacinian corpuscles, and they detect deep pressure and vibrations. We also have Merkel cells that sense steady pressure, and Ruffini corpuscles that respond to skin stretch or pressure. We perceive this by the receptor sending signals to the somatosensory cortex, helping the brain interpret touch and sensations across the body. And that is all. Hopefully this gives you a good foundation in sensory receptors and how they function. Thank you.